Imagine for a moment that you wake up in a universe where the air isn't breathable, water doesn't exist, and stars never formed. In fact, atoms themselves never came together. No galaxies, no planets, no life, nothing but an empty, silent void. Sounds terrifying, right? Well, the shocking truth is, that scenario could have easily been our reality. It all comes down to something profoundly mysterious, something that has baffled scientists. This is where the naturalness problem haunts modern physics. Physicists expected that the fundamental constants would arise from simple, elegant principles. They noticed something unsettling. The mass of the Higgs boson, the particle responsible for giving matter mass, seems absurdly low compared to what quantum mechanics predicts. That's where ideas like supersymmetry came from. The hope that for every known particle, there's a heavier superpartner that balances out these extreme quantum fluctuations. Why does the universe work at all? Some physicists proposed a multiverse, the idea that our universe is just one bubble in an unimaginably vast cosmic foam, where each bubble has different physical constants. In most of those universes, stars never form. Life never emerges, but we exist in the rare universe where the numbers just happen to be right. Because if they weren't T, we wouldn't be here to ask the question. Yet, perfectly tuned for chemistry to function. If it were different, stars wouldn't fuse elements properly. Or is the universe simply one lucky lottery ticket in an infinite multiverse? The truth is, ... We don't know. And maybe that's the most profound realization of all. That in all our technological mastery, all our scientific breakthroughs, we still stare into the cosmos with wonder, humbled by mysteries bigger than we can yet comprehend. And life-supporting molecules could never form. Why? 1836. There's no clear reason. It just ... is. This is called the anthropic principle. It's elegant in a way, but deeply unsatisfying. To many scientists, it feels less like an answer and more like a cosmic shrug. And ponder why the laws of physics exist might be the most extraordinary thing of all. Whether the answer lies in hidden symmetries, extra dimensions, divine design, or cosmic randomness, one thing is certain: the universe is far stranger, far more delicate, and far more profound than anyone ever imagined. For decades, massive experiments like the Large Hadron Collider dug deep into the fabric of reality, smashing particles together at unimaginable energies, hoping to find evidence of So if you love exploring the deepest mysteries of existence, from the edges of the cosmos to the smallest particles, make sure to hit that like button, subscribe to Beyond Stars, and join us on this journey into the unknown. Because the universe is waiting ... and the next answer might change everything. Maybe the constants aren't random. Maybe there's a hidden framework, some fundamental principle we've yet to discover that locks these numbers into place. But a feature, theoretical calculations suggest it should be 10,120 times larger than what we observe. If it were even slightly larger, the universe would expand so fast that galaxies could never form. Slightly smaller, and the universe would collapse back in on itself. Yet, ... here we are, balanced perfectly between nothingness and chaos. Some philosophers argue that consciousness itself might be woven into the structure of reality, that the universe isn't just a random collection of atoms, but a kind of cosmic machine designed to produce observers. That idea sounds almost mystical, ... but it raises a profound question. Is mathematics just something humans invented? Or is it the language reality is written in? The more we peer into the fabric of the universe, the more it seems disturbingly tailored for life, something deeper than the standard model, something that unites quantum mechanics and gravity, the great dream of a theory of everything. String theory is one candidate. It imagines that particles are actually tiny vibrating strings, and the different vibrations create different particles. But string theory also predicts an almost infinite number of possible universes, a landscape of realities, each with its own constants. Again, we're back to the multiverse, but the results were ... silence, supersymmetry, at least in its simplest forms, doesn't seem to be there. And suddenly, the naturalness problem became even more unsettling. Tiny quantum fluctuations should push the Higgs mass up to ridiculously high energies, unless, by some magical coincidence, an enormous number of wildly different terms cancel each other out with insane precision. This is what's called the hierarchy problem. A glaring example of the naturalness problem. Imagine balancing a pencil on its tip, not just on a table, but on top of a moving airplane during a thunderstorm. That's how unnatural this balancing act seems in the equations of the universe. But that's not what we see. Instead, we see constants with wildly different magnitudes. Gravity is 1,036 times weaker than the strong force. That's not a typo. That's a number with 36 zeros. Why? Shouldn't they all be roughly the same order of magnitude? Is this just a bizarre cosmic accident? And philosophers for decades, the fine-tuning of the fundamental constants of nature. These are the numbers written into the very fabric of the cosmos. Values like the strength of gravity, the charge of an electron, the mass of a proton, and the speed of light. And here's the mind-bending part. If even one of these numbers were just a tiny bit different, by a fraction of a percent, the universe as we know it would collapse into chaos. Stars wouldn't burn. Chemistry wouldn't happen. Life would be completely impossible. This is known as the naturalness problem, but it raises a haunting question. Is our universe finely tuned? Or is there something deeper going on beneath the surface? To really grasp how strange this is, consider gravity. Out of all the forces in nature, electromagnetism, the strong nuclear force, the weak nuclear force, gravity is by far the weakest. Think about it. A tiny fridge magnet can overcome the entire gravitational pull of the Earth. But why is gravity so weak? If it were just a little bit stronger, stars would burn too quickly, collapsing in on themselves before life had a chance to emerge. And galaxies wouldn't even form. Somehow, the strength of gravity sits in a razor-thin window where stars live long enough, planets form, and life gets a chance to evolve. Coincidence, or something more? Let's take the strong nuclear force, the force that holds the nuclei of atoms together. If it were just 2% stronger, hydrogen would never have formed after the Big Bang. Without hydrogen, there's no water, no stars like our sun, and no life. But if it were 5% weaker, the universe would be flooded with nothing but hydrogen. No heavier elements, no carbon, no oxygen, no planets, no us. The universe walks a knife's edge. But here's where the story gets even stranger. The electromagnetic force controls how atoms hold together. If the electric charge of an electron was slightly different, chemistry wouldn't work. Matter as we know it wouldn't exist. No molecules, no DNA, no brains pondering these mysteries. It's like the universe is programmed down to the finest decimal to allow for complexity. But who, or what, programmed it? This became a crisis when physicists started building models like the Standard Model of particle physics, the framework that explains particles and forces. For years, physicists believed there had to be an answer, some hidden symmetry, a deeper law, or an undiscovered particle that would explain this fine-tuning. If nature isn't naturally balanced, then others propose that we simply haven't found the deeper laws yet. But what if the fine-tuning isn't a bug in the system? Consider this: the cosmological constant, the energy density of empty space, as one of the most bizarre fine-tuning problems in all of physics. Even the ratio between the mass of a proton and an electron, about 1836 to 1, seems completely arbitrary. So what does this all mean? Are we characters in a cosmic simulation, crafted by some hyper-advanced intelligence? Is there a creator? But here's the most mind-blowing part. The fact that we can ask these questions, that atoms arranged in the form of a human brain can look out at the cosmos. If this blew your mind even a little bit, imagine how much more there is still to discover. We're just getting started.